Physics 2212 Lab 2, and landing in, we have that the purpose of this lab is to revisit the charge tape experiment in Lab 1 to reconsider the tapes as lines of evenly distributed point charges, and like before, we want to observe the forces between the two pieces of tape. And starting off with fundamental physics principles, we have that a net force is equal to dp over dt. We just needed to say that the forces are equal and opposite. And rotating to our forces, we have the gravitational force. The universal law is shown on screen, but for this lab we want to focus on gravity being equal to negative mg, where the constant g is shown on screen. And then for Coulomb's law, or electric force, we want to focus on the equation where the force is equal to the charge times the net electric field acting on that charge, and the electric field can be calculated by K, which is a constant that's shown on screen, times the charge over the distance squared times r hat. And then our model is a glow script model that recreates each of the tapes as lines of evenly distributed point charges, and it will calculate the forces acting on the top piece of tape. For the brief preview from Lab 1, we know that each tape has a positive charge, and you guys can see the amount of electrons lost along with the charge from Lab 1. But new to Lab 2, we found that the charge is 6.9 e to the negative 9 times the square root of 10 coulombs. And our system includes the top piece of tape, which we could call tape B. Our surroundings include everything else, like the bottom piece of tape and the earth. For gravity, our initial conditions are roughly the same as Lab 1, where the dimensions of the tape are the same, but this time we want to model the tapes with 50 point charges in each of them. And then to refresh you guys on the experiment in Lab 1, we charged up two pieces of tape by ripping them off of another piece of tape, and then we observed the interactions with those pieces of tape between our hands and those pieces of tape near each other. And for Lab 2, we only have a glow script model. And we start our code by having the constants and our initial conditions, and then after that we have the E field, which we calculate by finding the components to put into the equation. Then we just plug the equation into glow script. And then this part of code is basically just making each of the point charges that we will put in each of the tapes. For these parts of the code, we create our scale, we create both of the tapes, and then the bottom part of the code is basically just using the superposition principle to find the net electric field, and then we're using that to find the net electric force. And then for our final part of the code, we're basically just making the arrows to show the electric and gravitational forces along with printing out their magnitudes. This is the result of all of that code, and as you guys can see, the forces are roughly equal and opposite. And the main difference that everyone can notice is that the charges are different from Lab 1 as opposed to this lab, since they have different constants that are multiplied by e to the negative 9 coulombs. But the similarities are still there, since they're still both positive, and they roughly have similar magnitudes, since they're just constants multiplied by e to the negative 9. And the possible sources of error include human error with handling the tapes, and not having a concrete method to find a new charge, since we really just use the electric force equation in combination with trial and error to find that new charge. We also assume air resistance and drag are negligible. And for our magnitude on one tape, we found that to be 6.9 e to the negative 9 times the square root of 10 coulombs, and we did ignore air resistance, and we no longer consider the tape to be a single point charge for Lab 2, but this time as many point charges evenly distributed in a line. And we still assume that the tapes have the same amount of charge, And what if we had modeled each of the tapes as a single point charge? Then we probably would have gotten the same result as in lab 1. But this time we got a different constant to be multiplied by e to the negative 9 as shown on screen. And the estimates differ because of how we modeled each of the tapes, and the value from lab 2 is probably closer to the real value since we know tapes are not just a single point charge. Thank you.